We have a nice little extended kinematic problem here about a bullet coming out of a gun. Let's read it together. A bullet is fired from a gun. The muzzle velocity of the bullet is 223 meters per second. Muzzle velocity is how fast a bullet's going when it exits the gun or rifle or whatever it is that it's being shot from. Assume that the bullet accelerates at a constant rate along the barrel of the gun before it emerges. The barrel of the gun is 0.203 meters long. What is the weight of the bullet that was shot? Let me first explain some of this stuff. Bullet is sitting in the gun minding its own business. When you pull the trigger, that fires a little spark into some gunpowder, and that causes an explosion. Well, the explosion creates a bunch of very high density gas. Gas is under great pressure, and it wants to push the bullet out of the way, or it wants to expand, and the easiest thing to do is to push the bullet out of the way. So it pushes the bullet along the barrel, and then as soon as the bullet exits the barrel, the gases escape into the air. So while the bullet's in the barrel, it's being accelerated. We can tell this is a kinematic problem for a number of reasons. We have it says, the bullet's got some velocity and it's got some distance, and talks about acceleration being constant. So there's a lot of clue words here. So we're going to calculate how the bullet accelerated while it was in the barrel, and from that acceleration we're going to be able to figure out the mass of the bullet. Knowing that, we can figure out the weight of the bullet. So it's really 3 steps: kinematics, dynamics, and then dynamics one more time. Let's see how it works. Let's fill out our kinematic charts. The distance, again, we're looking at this problem while the bullet is inside the barrel. After it leaves the barrel, it's in free fall. That's a great kinematics problem, but not one for here. So the distance it travels in the barrel is 0.203 meters. Well, we weren't told anything about time, and we don't care anything about time in this case. So that's don't know, don't care. The bullet was traveling at 0 meters per second at the point before the explosion, and at the point it exited the barrel, it's at 223 meters per second. And as I said, we'll want to calculate acceleration here, because acceleration is what gets us over to dynamics. Well, that's a fairly straightforward problem. We'll solve it in a second. Let's go ahead and write down what we know about dynamics. Problem said the force was 900 newtons, and I'm looking to figure the mass. Once I know the mass, I can calculate what the weight is. So from the kinematics problem, don't know, don't care about time, leads us to Helen. We're looking to find acceleration, so I do a quick little arrangement of terms, and then I plug my numbers in as I know them from the problem. 223 meters per second squared minus 0 meters per second squared over 2 times the distance, 0.203 meters. You work that out, and it is a whoppingly big number, 122,485 meters per second squared. And that is something like 12,000 G's. So a bullet can take that. You and I couldn't. Explains why when bullets run into us, they do more damage to us than we do to them. Okay, well, that's the end of the kinematics problem. It is 120,484 meters per second. But then I use that to figure out the mass of the bullet, because it told me the force, and Newton's second law looks like this. I want to isolate for mass, so I do a little quick arrangement of terms, and then I plug my numbers in, and when I work that out, it comes out to 7.35 times 10 to the minus 3 kilograms is the mass of the bullet. There's 1,000 kilograms in a gram, so that would be 7.35 kilograms, 7.35 grams, which is about right for a bullet. Okay, well, that's almost what we need. We're not quite home free, because it asks for the weight of the bullet, not the mass of the bullet. So to figure out the weight, we need Newton's second law. Now, this is true always, but when we're looking at weight, there's a certain acceleration due to gravity near any massive object like the Earth, and that's going to cause the mass that we just calculated to undergo a certain force. That force is what I call it F sub g, force of gravity. You would call that weight. Okay, so we're looking to find its weight. It's already pre-isolated for us, so we just plug our numbers in. The mass we found in the previous step times the acceleration due to gravity, we're going to approximate it at 10 meters per second. And when we work it out, that's 7.35 times 10 to the minus 2 newtons. Not a whole lot of force there, but we'll see later when we talk about energy that there's a goodly amount of energy in this bullet because it's traveling so fast.